In this module, we will first discuss about the limit of a function. And remember that my aim is to teach you the calculus. So we start the calculus by functions, which I'm not discussing much here. I'll discuss about how to calculate limit of the function. And we have learned all this in standard 11. Okay. First of all, when I write a notation x tending to 2, x value approaching 2, the value of x is 1.9, 1.99, 1.999, etc. We say the value of x is approaching 2, or it can be 2.1, 2.01, 2.001. This is also approaching 2. Both the case we say the value of x is approaching 2. Now, when x value is approaching 2, what will be the value of x square plus 4x plus 5? So naturally, when x value is approaching 2, the square of all these numbers will be near 4. So x square will approach 4. X square will approach 4. That is 2 square is 4. And 4x will approach 4 into 2, 8. And 5 will remain as it is. So the whole function will approach 17. Which I can write as, which I can express as limit x tending to 2. Limit x tending to 2. X square plus 4x plus 5 equal to 17. Although we put equal to sign, it means that the value of this function is not exactly 17. It may not be exactly 17. It will approach 17. So when x value approaches 2, the value of this function will approach to 17. That is the meaning of this notation. So first part I have taught you how to write limit of a function. So if I ask you, calculate limit x tending to 1, 3x square plus 2x, what would be your answer? Directly replace x by 1 in the function. So 3 into 1 square plus 2 into 1 will give you answer 5. So my conclusion is, when x is approaching 1, the value of the function 3x square plus 2x will approach 5. Now, if I calculate the limit of this function, limit x tending to 1, x square plus 2 upon x plus 1. Here also I can use the same technique. When x is approaching 1, the value of x square is approaching 1 square, which is 1. It will approach 1. So finally, it will approach 1 plus 2 divided by 1 plus 1, which is nothing but 3 by 2. So when x is approaching 1, the value of this function approaches 3 by 2. Now let's look at the next one. Limit x tending to 1, x square minus 1 upon x plus 1. This answer would be 1 square minus 1 upon 1 plus 1. This will give me 0 by 2. Now let's have a look at this one. Limit x tending to 1, x square plus 1 upon x minus 1. Here what you notice is the denominator will become 0 and hence we said does not exist. Such a function do not come closer to any particular number. So the limit of that function does not exist. We will be dealing this further. So I can say conclusion like this. Majority of the function to calculate limit, I must directly substitute. That is, it can so happen numerator and denominator both are non-zero numbers. Then whatever the answer is your limit of the function. If the numerator alone becomes 0, the limit is going to be 0. This final answer is going to be 0. If the denominator alone becomes 0, then what we say, the limit does not exist or limit is infinite. This more further detail about this we can learn later. Then we come to my last case, limit x tending to 1, x square minus 1 upon x minus 1. In this case, the numerator also will become 0, denominator also will become 0. We call indeterminate form. If the limit of the function happen to be indeterminate form by direct substitution, then the direct substitution method will fail. So you are not supposed to apply the direct substitution method if you get an indeterminate form. What are indeterminate forms? 0 by 0, infinity by infinity, infinity minus infinity. All these are called indeterminate form. So if you get any of this indeterminate form in your calculation, that means direct substitution method of calculating limit should not be applied. So when can you do the direct substitution method of limit calculation? Only when the function's final answer is an indeterminate form. It should not be an indeterminate form. If it is an indeterminate form, then we need to use some other technique or formula to calculate the limit. If it is a determinant form, which you can determine these numbers. So direct substitution will be the method of calculating the limit. Now, we shall evaluate limit of a function when we get 0 by 0. And we are going to discuss here only algebraic function. Let's consider a function limit x tending to, let's say, 1, x squared plus 4x minus 5 divided by 3x squared plus 2x minus 5. How will we evaluate limit of this function? Now, when I substitute the limit, I will see that 1 plus 4 minus 5 will get 0. 3 plus 2 minus 5 will get 0. So it is indeterminate form 0 by 0. So direct substitution method cannot be applied in this particular problem. So what is my next option? Whenever we get 0 by 0, the numerator and denominator will have a common factor. And the common factor will be nothing but x minus 1. X is tending to 1, so the common factor will be x minus 1. So I can write this as x minus 1 into something divided by x minus 1 into something. So what I'll do? When I open this, it's a quadratic function. So naturally, the factor here will be linear. So the first term here will have x. X into x will give you x squared. Or you can do like this, x squared divided by x will give you x. Minus 5 divided by minus 1 will give you plus 5. If you expand this, naturally we'll get the same term. Same way here, 3x squared divided by x will give you 3x. Minus 5 divided by minus 1 will give you plus 5. Now we have got a common factor between numerator and denominator. Remember, in mathematics, this operation is wrong. I cannot cancel 0. If I cancel 0, a non-zero number can only be cancelled from both the sides. So we see two terms here which are equal. The question here is, can we cancel them? You cannot cancel them if they are zeros. If they are equal to 0, the cancellation property does not hold good. So what we do is, we ask the question, what is the value of x? The value of x is not exactly 1. The value of x is approaching 1. It is almost 1, but it's not exactly 1. Hence, x minus 1 will not be exactly 1. So I can say like this, because x is approaching 1, x is not equal to 1. So x minus 1 will not be 0. Because it is not 0, I can cancel them. Hence, my calculation of limit now turns to be x plus 5 upon 3x plus 5. And this will give me 1 plus 5 upon 3 plus 5. That will give me 6 upon 8. That is 3 by 4. So what's my conclusion? When x is approaching 1, the value of this function is not 0 by 0. The value of this function is 3 by 4. So when x approaches 1, this function's value will approach 3 upon 4. Now, let's calculate the value of the limit of this function. You have noticed that in each of the function, I made a small variation. It is x squared minus a squared, x cubed minus a cubed, x raised to 4 minus a raised to 4. And finally, I want to calculate the value of this formula, or I am going to derive this formula by generalization. So, first point that I do is to calculate this limit. If I do direct substitution, I will get a square minus a minus a. I will get 0 by 0. Hence, direct substitution cannot be applied. So, I have a common factor for numerator. I will have a common factor for denominator. And I can cancel the common factor. And after cancellation of common factor, I'll get the answer a plus a. That will give me 2a as my answer. Now, let's have a look at the next one. Here, I'm going to apply a cube minus b cube formula. When I apply a cube minus b cube formula, x minus a into x square plus ax plus a square divided by x minus a. So again, x minus a will get cancelled. You will be getting the answer as a square plus a square plus a square, which will give me 3a square as my answer. Very interesting to note. The power is 2, a's power is 1. Power is 3, a's power is 2, because one common factor reduces x power. Let's have a look at the third one. Limit x tending to a. Now here I am going to factorize this way. X square minus a square into x square plus a square divided by x minus a. Now, we already calculated the limit of this as 2a. You may directly substitute this as 2a. So I can write limit x tending to a, x square minus a square upon x minus a, this first part. And this I'm taking separately, x square plus a square. So my answer will become here 2a, and here it will become 2a square. And finally, my answer is 4a cube. My aim was to generalize this formula. When the power is 2, we ended up in a. Power is 3, we ended up in a square. Power is 4, we ended up in a cube. So the power is n. What will be a's power? 1 less than n. So a's power will be n minus 1. When the power is 2, the value started with a 2. Power is 3, value started with 3. Power 4 started with 4. So power n will start with n. So here is a formula for you. Limit x tending to a, x to the power n minus a to the power n upon x minus a will be always n into a raised to n minus 1. The power into 1 power less than the original. Original is a raised to n, it will become a raised to n minus 1. So if I want to calculate limit x tending to a, x to the power 10 minus a to the power 10 upon x minus a, I need not find all this common factor. Directly I can apply this formula and write the answer as 10 times a to the power 1 less 9. Original power 10, it become 9. So the power will start with the power, reduce the power by 1. This is how you can apply this formula. Now let us discuss the three types of problem. We are using the formula limit x tending to a, x to the power n minus a to the power n upon x minus a is n a raised to n minus 1. We are going to apply this formula in these three problems so that we can evaluate it in a faster way. Now you have seen that x power and a's power should be same to apply this formula. So the condition to apply this formula is if x is tending to 3, x power and 3's power should be same and it should be x minus 3. The difference of this both should be the denominator. So I can write this way, limit x tending to 3, x to the power 4. Naturally, 81 is 3 to the power 4. Otherwise, you cannot apply this formula. And now you can see that it is exactly in this format. So directly I can write the answer 4 into 3 cube. That is 4 into 27. That is 108. So in case of such format, if the function happened to be in this format, you don't have to get common factor. You don't have to cancel the common factor. Directly you can apply. Only thing that you need to remember is the function in the same format? What is the format? If x is tending to 3, denominator should be x minus 3. Power of x and power of 3 in the numerator should be the same. Power of x and power of 3 in the numerator should be the same. Then directly look at this and write your answer. 4 into 3 to the power 3. Now let's have a look at this. Here, the denominator is not satisfying the condition. X is tending to 2, but it's not x minus 2 here. What I'm going to do here is, I'll make a small adjustment. I've noticed that 2's power is 6. 64 is 2 x raised to 6 minus 2 raised to 6. No problem. Divided by x raised to 4 minus 2 raised to 4. Now, what I'll do is, I'll make numerator into a formula and denominator also into a formula by dividing numerator and denominator by x minus 2. Now, numerator turned to be a formula, denominator turned to be a formula. Now, I can apply the formula. So, 6 into 2 raised to 5 divided by, the power here is 4, 4 into 2 to the power 3. Now, I can write this as 6 by 4 is 3 by 2. 2 raised to 5, 2 raised to 3. So, difference is 2 square. And that 2 square and this 2 get cancelled. Final answer is 6. Let's look at the third one. Can we apply for rational numbers this formula? Yes, we can also apply this for rational numbers too. We can apply for natural numbers, you can apply for integers, you can apply for rational numbers too. So here x is tending to 1. So x 1 raised to any number is no problem to you. So x raised to 3 by 2 minus 1 raised to 3 by 2 divided by x raised to 5 by 3 minus 1 raised to 5 by 3. Now what should I do to make this into formula? I need to convert this into formula. So what I should do? Numerator and denominator, you divide by x minus 1. If you divide numerator and denominator by the same quantity, no change to the function. Now we can apply the formula for the numerator. 3 by 2 is the power into 1 raised to 3 by 2 minus 1 divided by 5 by 3 into 1 raised to 5 by 3 minus 1. Anyway, 1 to the power any term is 1 only. And so I can finally write 3 by 2 multiplied with 3 by 5 is equal to 9 by 10 becomes my answer. So the final answer for this function is 9 upon 10. So this is how you can apply this formula.